Yes, that's where we're at?
Yes.
Okay. All right, I don't really have to tell you to do much here. I'm just going to say do it. And that is, take your function, f of x equals this, right? And then find the value of the function when x is what? 2. Go. It's just you now. You just do it. You got what? 6, okay. 8 plus 4 take away 6 is 12. Take away 6 is 6, right? So, okay, talk to me. If somebody said this to you, f of 2, and you say f of 2 is what? What is the answer? 6. Okay, so when x is 2, this is what? But what's this? This is x. This is y. X, y. Sounds like a what? Sounds like a point. You could also write it how? 2 comma what? 6. Good. Did that in what grade? Ninth grade, probably. F functions were brought up in 9th grade, probably algebra 1. Okay. Now, do this one. Notice this polynomial. And now notice this polynomial, they're what? Same thing. Except I want you to do what? Divide this polynomial by this polynomial. And because it's linear, which way do you think I want you to do it? Long or synthetic? Well, you guys will want to do it long. Do it long. Why are we picking long though? Synthetic's if there's another name for synthetic, it's what? Short division. Would you rather do it short?
No.
Okay, do long. Whatever. Go. Do it. I put the next number, I put 1 in. What's the next number?
0.
Yeah, 0. Then 2, then negative 6, right? What's the number on the outside? What am I doing wrong? Oh yeah. I'm thinking too far ahead. I'm thinking of the next slide. I'm sorry, guys. The answer is what? 6. Right? Answer 6. Okay, hang on. So if I said, what's the answer to your division problem? This divided by this, the answer is what?
X plus 2x
Plus what?
6 over.
The remainder is 6 over the divisor. X minus 2, right? So divide this by this. Yeah, that's the answer for division. But that's not where I was really going. I wasn't really going there. I want you to notice, when you divided by x minus 2, what did you stick out here? You put a 2 out here. Then you worked it out, and got a remainder of what? 6. 2, then 6. 2, then 6. Look. 2, then what? 6. So what happens is this. If you're ever told, evaluate a function f of 2, f of 3, f of 4, you can get the answer not by direct substitution. You get the answer by using what? Synthetic. Say synthetic. Division. Synthetic division will get you that answer 6 if you just look where? The remainder is the answer to evaluating a function. So what you're supposed to notice is, oh, that answer 6 came can come from synthetic division. You can do it this way every time. So if I asked you on the test, on the quiz next week, what's f of 10? What would you do? You'd put 10 into your function. You could do it the long way, which is
Put
this
it
way.
where the thing.
Or yeah, just put it right here, right? Put a 10 there. Whatever this is, I mean, let's just pretend it's 26. Well, now f of 10 equals what? 26. That's how easy it is. If you're good at add, multiply, add, multiply, add, multiply, this is really easy. It's pretty slick. Or maybe you like doing that stuff. I don't know. What do you, I mean, it's up to you. But I will tell you this. You are forced to do it this way on the what? Quiz, test, okay? Because it says right on there, use synthetic division to help you find f of what? 2, okay? Now, you're going to do all this work. Here's what's going to happen on the quiz. You're going to do all this work, and then you know what you're going to circle for your answer? You're going to circle this, and you're going to say, that's the answer. Well, that was the question. Do you think that's the answer to this? No. F of 2, 2 goes in, what comes out? 6. The answer is what? What's this called? The remainder's the answer, okay? Does that make sense? Okay, that's that easy. Okay, next slide. Next slide. Oh, the remainder theorem. I was just talking about the remainder. If a polynomial f of x is divided by x minus k, isn't that what we just did? If a polynomial f of x is divided by x minus k, the remainder equals what? F of k. Yes, sir.
It is.
I am recording. That little black dot means I am. But thank you. Everybody okay? So if I said you are dividing by x minus 10, then this would mean f of what? 10 equals what? The remainder, right? Or what if I was dividing by x plus 6? Now what? F of what? Negative 6 equals what? The remainder. That's what they're telling you. It's called the what theorem? Remainder. Okay. So, ready? Here we go. Use polynomial division to find f of negative 2, given that this is your function, and I don't want you to directly substitute it in. I want you to use what? I didn't say it. I want you to use what? Synthetic division to help you find f of negative 2. Go. You did this yesterday, so this should not be very difficult. Okay, here we go. Use the polynomial division, synthetic division, to find f of negative 2, given that this is your polynomial. I want to let you know, when you're evaluating at negative 2, it's the same as dividing by what? X plus 2, right? And if you were dividing by x plus 2, you'd put what over there? You'd put a negative 2, wouldn't you? Yeah. So you put the negative 2, you bring the numbers down, multiply, add, multiply, add, multiply, add, and multiply. What's the answer? 5. So how do we write this answer? Yeah, they want this, they want that answer. What is it? Yeah. 5. It's another way to evaluate a function. You don't have to put the number in and work it. You can just simply do synthetic division and understand the remainder is your answer. Good? No questions, right? Okay. Questions? All right, nobody says anything? Yes, Randy. What? Oh, yeah, go. Okay. All right, that was the remainder theorem. This is the what theorem? Factor theorem. Okay, factor theorem. A polynomial f of x has a factor of x minus k if and only if f of what? F of k is equal to what? 0. Okay. So can I show you this? If that's true, if I tell you f of 6 is equal to what? 0. So if f of 6 is equal to 0, you have to realize that's a point. That's what? 6 goes in. What comes out? 0. So 6, 0 is a point on your graph, but 6, 0 is an x-intercept. So if I go up here and I go like this, and I go 6, 0, oh, that's an x-intercept. That's a solution. But that's also a what? It's a factor. 6 came from one of your factors in your polynomial. So you got to kind of say, what is that going to be? What's the factor? X what? Minus 6. So all they're saying is if you know you can plug a number into your function and get 0, oh, you found an x-intercept. Well, x-intercepts, you know what they are? They're just factors. X minus 6, right? What if I put a negative here? Oh, negative 6 comma 0. That would mean what? It's going to be instead what? X plus 6, okay? Just putting numbers in so it makes a little more sense. Okay, next, look at this one. This one says to use synthetic division to determine, is this truly a what? Is it a factor? How do you know if it's a factor? To what? Synthetic division, right? Okay, so numbers are going to be what? Say my numbers. Okay, and if this is truly a factor, right, then the remainder better be what? Yeah, you better have no remainder. Because factors are numbers that go into other numbers evenly, right? Okay, so what do I put out there? Yeah, you're going to divide division by that. You're going to have to say, is 3 a 0? Work it out. See if you get 0. It is? Okay. Let's hope. Well, I got 0. Did you? Okay. So, I mean, just looking up there, guys, your function has a factor of x minus 3 if and only if f of 3 is going to be equal to 0. Is f of 3 equal to 0? Yep. Yeah. So is x minus 3 a factor? It is a factor, yes. Why? Because the remainder is what? 0. The remainder is 0. Period. That makes sense, doesn't it? If the remainder is 0, you found a factor. So guys, watch. If I put 15 up here, and I say 5, is 5 a factor of 15?
Yes.
Sure it is. Why?
3.
Because 5 goes in here what?
3 times.
3 times 5 is?
15.
Subtract. What's your remainder? Because you got 0, 5 goes in there evenly, so 5 is a factor. Which means x minus 3 goes into this evenly, no remainder. Okay? That's where they're going with this. Okay? I'll show you why in a second. Oh, okay, and this is just, you're supposed to go to your book, page 155. Find the uses. What are the uses of the remainder in a synthetic division problem? If you say f of k, you put this in, this is always going to equal what? The remainder. Okay, so what if your remainder happens to be 0? Then what? Then what? Not good enough. Close. X, there you go. Then x minus k is a what? Is a factor. Okay? So when you use synthetic division, this helps. Oh, I plug in k, I get the remainder to be what? Oh, well then x minus k is a factor. What else? What else happens? Then what? It's a what intercept? It's an x-intercept. So then what? Then k comma 0 is what? The x-intercept. Right? I can throw numbers in for you, but I think you get it. Any questions? Day 2. Ready? We're just going to start. 4748 I canceled, but 4748 is, I only canceled because the word is so weird. So I have to kind of go over it. Okay. Dig out your assignment for today. I think today you have 8 problems. I'll try to do 2 of the 8. You'll leave me with 6 to do. Okay? All right. I got to show you something that I did not show you yesterday. Okay? This is what you were doing yesterday. You were taking a polynomial and you were dividing something into the polynomial. And what they do in this is they go like this. They call the polynomial f of x. So whatever you're dividing into, they just call it f of x. Then typically you guys are dividing by a linear factor x minus k. You don't really have to write this down if you just watch. Disagree, raise your hand. Agree, just do anything. Take a polynomial f of x, divide by x minus k, and what you're going to get is some kind of answer. And the answer is known as a what? The answer to division is known as what? Quotient. They call that q of x. Okay? Then you do all the work, right? You work, and you get a remainder of whatever. Let me just call it R. Got it? Now, looking at those words, how do you check? How do you check if this is all right? Multiply what? The quotient times the divisor. Okay, so can I do this? Q of x, whatever that answer is, times what? X minus k, right? And then what do? You add the remainder, and what do you get? The polynomial inside, known as what? All right. Guess what? Number 47 and 48, they want you to write your answer like this. That's what was so confusing about 47, 48. They're telling you to write your answer like this. So whatever you're dividing into f of x should equal the answer times the divisor plus the remainder. Should we get started? 47. Here we go. 47, I canceled it yesterday. Now let's start over and just do it. All right, here we go. 47. We're going to do it synthetically, guys. I don't want to do long division. Okay? This is what? This is from yesterday's homework. I canceled it. Now we're going to pick up right at 47. Okay? Somebody tell me the function that we're dividing into. If you just want to tell me the coefficients, I'd be happy.
1, -1, -14, 11.
11?
Yes.
Okay. And I'm dividing by what?
4.
Okay, yeah, I think it said k is 4. X minus 4. So what do I put out here? What? 4. Guys, didn't it say something like divided by what? x minus k. And then later in the back of the problem, it said let k be what? 4. So if you're dividing by x minus 4, what goes out in front is 4. Okay, start. Yes or no? Yeah, okay. So this is the answer to your division. But tell me what that 1, 3, negative 2 actually says. And then that's the remainder, right? Okay, remainder 3. Okay. But remember what they said. Write your answer like this. So actually they're telling you, whatever you divided into, whatever you were divided into, which is this, right? So I could say, this must be x squared. Okay, so the function I started with was x to the what? Third minus 14x, right? Plus 11 should equal the answer times the divisor plus the remainder. So what's the answer? Yeah, that's the answer, right? So this plus this minus this, that's a 2. Times what? X minus 4. Then what? Yeah, don't say over, just because if you ever want to check an answer, you take answer times divisor, add whatever the remainder is. You don't add the fractional part, you just add the remainder. Anyways, that's it. And you know what this side says? You know what you're really doing over here? What are you really doing over there? You're foiling, okay, but aren't you checking your answer? This is just another form of saying, check your answer. Take answer, times divisor, add remainder, see if you get what you started with. All right, are we going to do this? No. Just write your answer like that. 48's the same thing. Okay. Now, last period, we stumbled on this problem. This next problem is a great problem because it's asking you just about everything you learned. It's problem 69. Go to it, try it, just get started. Okay, and I'll catch up to you. When we're done with this problem, you only have 6 to go. Okay? 6 problems. 48 you'll do, and then you only have 2 more. We did. Where are you at? Okay, we did 46. We did 48 and 6. We have 7. I'm going to do 6. Oh, yeah. Gotcha. All right.
Yeah,
You never found it, did you?
No, I didn't.
And that's it right there?
I'm not far.
Okay, got it. Okay, help. Somebody just read me the function. Alphabet. X to the 4th, then what?
Minus 4x to the 3rd.
Okay.
Minus 15x squared.
Okay.
Plus 58x.
Okay.
Minus 40.
Minus what?
40.
All right. Nice long function. Ready? Part A says what? Oh. Verify the given factors. What are the given factors? X minus 5 and x plus 4. Okay. Okay. So these are factors of that. They're telling you they're factors. So if they're factors, just prove it that they are. How do you prove it? What?
Add, put
Put the
the numbers in.
numbers just in.
Synthetic.
I do synthetic division and then prove that the remainder is what? 0. That's what I do. So let's prove the first one. Is this a factor right here? Well, how do you know? You'd probably quick do synthetic, I hope, right? 1, -4, -15, positive 58, -40. If it's a factor, what's this number right here? 0. Okay. Put the 5 out there, right? Put the 0 in front. Is 5 a 0? Let's see. I got it. Did you get it? So can I do this right now? Check. It is a factor. Got it. X minus 5 goes into that number evenly. Remainder 0. So it's a factor. Okay. What about x plus 4? Is it a factor? How do you know? How do you prove it? What? Synthetic division. Do I have to start all over? No! You guys, look. Wait, get your eyes up just a second. Hey, I know 5 goes into 100. How many times? 20. Remainder is what? 0. Okay, now, does 2 go into 20? Well, here, let me say it this way. Does 5 go into 100? Yes. Does 2 go into 100?
Yeah.
Yes. But do I have to start with 100? No, I can just move on over and go what? 20 divided by what? 2. Oh, the answer is what? 10, because the remainder is 0. What I'm saying to you is you don't have to start over with these numbers. Now go like this. Just go with the next group of numbers. Put what in this time? Oh, I messed up. Sorry, don't look at that. My fault. Should have been -4, right? Check to see if -4 gives you a 0. Did you get it? I got 0. Check. I did it. I proved that the given factors were zeros, or were factors by seeing if the remainder was 0. I know I should have got 0 because they told me they were factors. Good? How about B? What does B want? Say that again.
Find the remaining factors.
Okay. Now, what you might not get what they're saying. The remaining factors. They gave you 2 factors. There's more factors. Well, if these are given to you, you kind of know this, don't you? X minus 5 times x plus 4 times, there's more. Okay, how are you going to know what the more factors are? What? Well, if this is a factor and this is a factor, then you take the 2 factors times more factors. Where are these more factors coming from? The answer to your division, right? Okay, maybe you don't get it. Maybe you don't get it, maybe you do. Okay, how about this? 2 is a factor of 100, correct? Because it's what? 50. Okay, keep going. What goes into 50? 5. Okay. How many times? 10. Is that all there is? Is it just 2 times 5 is 100? No. Keep going. 10. What goes into 10? 5. Okay, twice. What goes into 2? 2, 1, or yeah, once. So you got factors of this, 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 this. 2 times 5 times 5 times 2 is 100. There's more. And where they come from are right here. This is the other factor that's left over. Put it in there. Okay. They want the remaining factors. Okay. Well, I'm going to write this in black. The remaining factors are, who's got them? So they come from here. X what?
Minus 2.
And X what?
Minus 1.
Okay, there's the remaining factors. So that's part B. So when you do this synthetic, these are the answers that are left over, but these other these answers can be factored again. So these are the remaining factors. Keep going. Part C. I'm listening.
Use your results to write the complete factorization of them.
Oh, okay. So completely factor it. So if I completely factor it, it's going to be these two given ones, right? Times what? The two remaining ones, which are whatever, x minus 2, x minus 1. Got it. So you're using those two to just finish it. How about D?
List all real zeros of F.
Oh, you want zeros? Set it equal to 0. What are the zeros? 5, -4, 2, and 1. Yeah? Okay. E. Told you this is a good problem. Use your graphing calculator. I'm going to cheat. Ready? My graphing calculator, I know what it's going to say because, look at this, I know the zeros. What are they? Yeah, but these are also known as what? X-intercepts. 5 dot, 2 dot, 1, and -4. Anybody know the end behavior of this thing? Hey guys, it was an x to the what? 4th. Even act like Brad was. Which way? Up, up. Here. Up on the left, up on the right. I know my calculator is going to do that. You know what else you know? Starts with M. Yeah, you know the multiplicity. What's the multiplicity here? 1, 1, 1, 1. Odd multiplicity means it bounces or goes through. It goes through. So guess what? They're all 1, 1, 1. They're going to go through really slow or fast. They're going fast. They're going to go through. But what I don't know is this. I don't know when it hits the 0 how high or low to go. I mean, no idea. I mean, it could go way down. But if you really, really want to know how far up and down it goes, do it on your what? Yeah, the calculator will tell you. But I do know it's going to look something like that on my calculator. Now, just a quick question before I turn you loose. Ready? What would happen here? Right here. What if that was a 2? Right at 5, it would have what? It would have bounced and went back down. But that would have changed that. It's no longer even, it's what now? And it's not just, it's odd, but it's also what? It's also negative. Because it's going up and down. So it's a negative line going down. Those are all clues that I've given you in the last 4 or 5 days. This has been a huge week. You made it through what I call hurricane season. You do realize I taught you 2, 1, 2, 2, 2, 2, 2, 3, 2, 3, right? It was a 5-day week and a 5-lesson week. Are you okay? Are you emotionally fine? Are you okay? No one's crying, no one's, right? Okay, next week I promise will be very little teaching. It will start with review on Monday, and then I think I'm gonna give you the 2-4 just give you an extra day to get ready for the quiz. The quiz is what day? Wednesday. You have a quiz on Wednesday. We're going to end the week with a quiz, and then you're going to get out of here and enjoy what? 4-day week. Okay. You have 6 problems to do. That's it.